NCM Learning Center. Good morning friends. In this video, we are going to discuss about the excitation of synchronous machines. We will discuss what will happen when the synchronous motor is under-excited and over-excited. Similarly, we will discuss what will happen when the synchronous generator is under-excited and over-excited. Okay. The outline of the topics are, first we will discuss the basic points. Then we will discuss the effect of armature current and power factor on under excitations and over excitation of synchronous motor. Third, we will discuss the effect of armature current and power factor on under excitation and over excitation of synchronous generator. Okay. Finally, do it yourself. I will list few questions. You have to solve these questions. Okay. We will discuss one by one. First, we will discuss the basic points. First, what is meant by excitations? We know that synchronous machines operations. For synchronous machines operations, rotor side we have to give the DC supply. So excitations means applying DC current to the rotor field winding to increase the rotor field flux. So by the excitations, it will increases the induced back EMF of the synchronous machines. Okay. Next, then what is meant by under excitations? Under excitations means if induced back EMF is less than terminal supply voltage, that is called as under excitations. Next, what is meant by over excitations? Over excitations means if induced back EMF is greater than terminal supply voltage, then it's called as over excitations. Okay. Next, what is meant by lagging power factor? Lagging power factor means if current lags the applied voltage, then it is called as lagging power factor. For the lagging power factor, the machine will consume the real and reactive power. We have to remember this point. Okay. For the lagging power factor, the machine will consume the real and reactive power. Then, what is leading power factor? Leading power factor means current leads the applied voltage. So it is called as leading power factor. Under the leading power factor, the machine will supply the real and reactive power. Now, we will discuss the comparison of synchronous motor and synchronous generator during under excitations and over excitations conditions. During the under excitation conditions, the synchronous motor will act as synchronous motor. For the under excitation conditions, the synchronous generator will act as synchronous generator. Okay, the behavior will not changes for under excitation conditions. But the over excitation conditions, the synchronous motor acts as synchronous generator. That means synchronous condenser. The synchronous generator will act as synchronous motor. Okay, for the over excitation conditions, the behavior of the synchronous motor and synchronous generator changes. Synchronous motor acts as synchronous generator acts as synchronous motor for the over excitation conditions. Okay, we got to remember. Then we know that for motor, it will consume the real and reactive power. So the synchronous motor consumes the real and reactive power from grid or any source. Okay, this synchronous generator will supply the real and reactive power to the grid or any load. Okay, so here the synchronous generator will act as synchronous generator for the under excitation conditions. So it will supply the real and reactive power to the grid or load. Here under over excitation, the synchronous generator will act as synchronous motor. So we know that synchronous motor behavior. The synchronous motor will consume the real and reactive power from grid or any source. Okay. Next, if it is consumes, what will be the power factor? If it is consumes, the power factor will be lagging power factor. If it is supplies the power, means it is a leading power factor. Okay, here it supplies the power, so leading power factor. Here it consumes the power, so lagging power factor. Lagging power factor means it will consume the power. Leading power factor means it will supply the power. That is the difference. Okay. Then another one point. If synchronous motor acts as synchronous motor, or otherwise synchronous generator acts as synchronous generator, means the armature reaction will be magnetization and cross magnetization. If synchronous motor acts as synchronous generator or synchronous generator acts as synchronous motor, then the armature reaction will be demagnetization and cross magnetization. We got to remember. Okay. The behavior does not change. synchronous motor or synchronous generator behavior does not change means the magnetization and cross magnetization effect will happen. If the behavior of the motor or generator changes, then the armature reaction will be demagnetization and cross magnetization. Okay, here the synchronous motor behavior does not change. Synchronous motor acts like synchronous motor. So magnetization and cross magnetization will happen. In this condition, the synchronous motor acts as synchronous generator, a synchronous condenser. For that case, the armature reaction will be demagnetization and cross magnetization. Here, for the synchronous generator, during the under excitation conditions, the behavior does not change. The synchronous generator acts as synchronous generator. So, the armature reaction will be magnetization and cross magnetization. Okay, here for the over excitation conditions, the synchronous generator will act as synchronous motor. The behavior changes. So, the armature reaction will be demagnetization and cross magnetization. This is the point. This is the comparisons. This point is very important for the examinations. Okay, the comparisons you should remember. Then we will give the justifications for the point by discussing effect of excitation on armature current and power factor. First, for a synchronous motor, you should remember the U characteristics. U characteristics of synchronous motor. Okay, characteristics curve. U curve. The shape is in U shape, so it is called as U curve. Okay. But under excitation conditions, the synchronous motor acts as synchronous motor, so it will consume the power, so it will be lagging power factor. Under over excitation conditions, the synchronous motor will act as synchronous generator, so it will supply the real and reactive power, so it will be leading power factor. Okay. By the curve, the armature current is very minimum at unity power factor. Then, when the excitation increases from E1 to E2, then the armature current will be increases, leading. Okay. Third, when the excitation decreases from E1 to E3, E1 to E3, the excitation decreases. What will happen? The armature current increases, lagging power factor. Okay. So under unity power factor, the current armature current is very minimum. When the excitation increases from E1 to E2, armature current increases, or when the excitation decreases from E1 to E3, the armature current increases. Okay. Next, we remember that power factor curve, inverse U curve. Inverse U curve. So the power factor will be maximum at unity power factor. When the excitation increases from E1 to E2, power factor decreases, or when the excitation decreases from E1 to E3, the power factor decreases. Okay, this is the basics. For the synchronous generator, similar characteristics. It's also a U-shaped curve, but lagging and leading forward will only changes. Okay, for a synchronous generator, during the under excitation conditions, it will act as synchronous generator. Synchronous generator means it will supply the real and reactive power, so leading power factor. Under over excitation conditions, the synchronous generator will act as synchronous motor. Synchronous motor means it will consume the real and reactive power, so it will operate in lagging power factor. Okay. So armature current will be very minimum at unity power factor. When the excitation increases E1 to E2, the armature current increases. Or otherwise, if excitation decreases from E1 to E3, the armature current also increases. Okay. Next, for the power factor curve, similar curve, inverse U curve. So the power factor will be maximum at unity power factor, decreases when the excitation increases or decreases. Okay. Okay. Now we will give the justifications for the characteristics. First, for a synchronous motor, we know the equivalent circuits of synchronous motor. The field winding DC supply is given to the rotor. Okay, this is for a stator, AC supply is given, 3-phase AC supply is given. Okay, this is induced EMF. This is armature winding, this is field rotor winding. Okay, this is rotor armature coil. So armature resistance is very minimum. Remember that. Okay. So the equivalent equations for the synchronous motor is V is equal to IRA plus IAXS plus EB. Back again. So rewrite these equations. EB is equal to V minus IRA minus IAXS. For armature coil, inductive effect is higher, resistive effect is very small. So we may eliminate this drop, IRA drop, because armature resistance is very minimum. So we may neglect. Now the equations will become like this. EB is equal to V minus IAXS. It will make the concept understanding is easiest. Okay. Okay, good. Now we go to draw the basic diagram. This is a terminal load supply voltage. V is a terminal supply voltage. It's a reference point. Next, consider initially the synchronous motor act at unity power factor. Unity factor means voltage and armature current are in phase. So we may draw this because we consider that unity power factor. Unity power factor means voltage and the currents are in phase. Okay, we know that IARA is in phase with IA. The basic points. IARA is in phase with IA. IAXS inductive 90-degree phase difference with IARA or IA. It's the basic points. Now we go to draw the IAXS with 90-degree phase difference with IA. Here IAXS negative value. So we go to draw this IA1 axis. IA1 axis is 90-degree phase difference with IA1. Okay. It's a negative value. So we go to draw in downward directions. E is equal to phasor addition of V and I axis. So we'll get this. This is the E1 value. Okay. Clear? Okay. Here E1 is the excitations at unity power factor. Now when the excitations increases from E1 to E2, what will happen? We know that for synchronous motor the input power is constant. So we will draw the constant power line. Okay. If excitations increases from E1 to E2, here E1 to E2 increases, excitations increases, the length of E1 increases, magnitude of excitations increases, E1 to E2. Now what value of IA to XS? This is IA to XS. Compare IA1 and IA2. The length of IA1 XS is smaller than IA2 XS. For this diagram, compare this. Length of IA1 XS is smaller than IA2 XS. It means that the armature current value increases. Now, what will be the effect on power factor? We know that the phase difference between IA1 XS to IA1 is 90 degree. Okay, always the phase angle difference between IA1 and IA1 XS is 90 degree. Okay, so if IA1 XS is shifted in counterclockwise directions, if it is shifted in counterclockwise directions, IA1 also shifted in counterclockwise directions. So it will get this. Because always the angle between IA and IA XS is 90 degree. So if it is shifted in clockwise directions, it will also shift in clockwise directions. To match the phase angle difference is 90 degree. Okay. Initially, under even conditions, the phase angle between the voltage and the current is 0. Unity power factor. Now the phase angle increases. The phase angle increases. So the phase angle increases from 0 to pi 2. Okay. Now what will be the power factor? The power factor will be decreases. Power factor from unity to lead but decreases, because if phase angle increases, the power factor will be decreases. For example, if phase angle is 0 means cos 0 1, power factor will be maximum. If phase angle is maximum 90 degree means cos 90 is equal to 0, the power factor will be minimum. So the phase angle and power factor is inversely proportional. If phase angle increases means power factor decreases. So the power factor decreases from unit to heat. Okay. Then if excitations decreases from E1 to E3, what will happen? Okay, it decreases. The length of E3 is lesser than E1. It means as the excitations decreases. Okay. Now the drop IA3 X3 will be like this because E is equal to V minus IXS. Okay. Compare this length and this length. Here IA3 is greater than IA1. IA3 is greater than IA1. It means that armature current increases. Armature current increases. What will be the phase angle? Here IA1 XS shifted in clockwise directions. Similarly, the armature current will be shifted in clockwise directions because to match the 90-degree phase angle difference. Okay, from here to here, clockwise direction movement in clockwise directions. Here IA XS movement in clockwise directions. Similarly, IA will be in clockwise direction movement. So okay, the phase angle will be pi 3. So the phase angle increases from 0 to pi 3. Phase angle increases. If phase angle increases means power factor decreases. So it changes from unity to lagging power factor. Okay, this is the concepts. That is why we will get for synchronous motor only at unity power factor or the armature current will be minimum. When excitation increases or decreases, the armature current increases. Similarly, for power factor will be maximum at unity power factor excitations. When excitations increases or decreases, power factor will be decreases. Phase angle increases, but power factor decreases. Okay, good. Now justifications for synchronous generator. Similar concepts. We know the equivalent circuit of synchronous generator. This is rotor side. This is stator armature side. It supplies the power. For synchronous generator, it supplies the power. So the equations will be EB back EMF is equal to V plus IRA plus IXS. For the stator armature coil, we may neglect the armature resistance. We are very minimum. So the equations will become like this: EB is equal to V plus IXS. So draw the phasor diagrams. First, V as a reference point. Consider the synchronous generator initially operate at unity power factor. Okay, consider that. If it is unity power factor, the voltage and armature current will be in phase. What will be the reactance drop? Reactance drop IXS is 90-degree phase difference with IA. So we'll get this 90-degree phase difference. Because positive. Positive means upward directions. Negative means downward directions. Here positive value, so upward. Now the back EMF will be addition of voltage and this drop. So we'll get this. This is the E1. This is E1 means excitations at unity power factor. IA1 means armature current at unity power factor. Okay. So we know that for synchronous generator, it will deliver the constant power. Synchronous generator will deliver constant power. Output power is constant. So we go draw the constant power line. Similarly for synchronous motor. Now when the synchronous generator excitations increases from E1 to E2, what will happen? Here excitations increases. So the E2 length is higher than E1. That means excitations increases. Okay. Now the drop will be like that. Because back EMF is addition of voltage and this drop. Okay. Compare this length and this length. IA1 XS length is smaller than IA2 XS. It means that IA1 is smaller than IA2. Okay. So armature current increases. When the excitation increases, armature current, this length is increases. Okay. Now what will be the effect on power factor? The IA1 axis shifted in clockwise direction. IA1 axis shifted in clockwise direction. So armature current also shifted in clockwise with the same angle, clockwise, because IA1 axis changes from this point to this clockwise direction. Okay, similarly IA1 also changes in clockwise directions. Then only we will get the phase angle difference is 90 degree. Okay, so phase angle increases from 0 to pi 2. Phase angle increases from 0 to pi 2. So power factor will be lagging power factor. When the excitations increase from U1 to U2, power factor changes from unity to lagging power factor. Power factor decreases. Then when the excitations decreases from E1 to E3, what will happen? Here E3 length is smaller than E1. It means as excitations very smaller. Okay. What will be the drop? This will be drop. Compare this length and this length. So IA3 is higher than IA1. So when the excitations decreases, armature current increases. Armature current changes from IA1 to IA3. Armature current increases. Okay. Then what will be the power factor? Here, if excitations decreases from E1 to E3, the drop IA1 IA axis changes from IA1 axis to IA3 axis. Okay, it will move in counterclockwise directions. It will move in counterclockwise directions. So the armature current will also move in counterclockwise directions to match the phase angle difference between armature current and this drop IA axis is 90 degree. Okay, so the armature current moves in counterclockwise direction with a phase angle of pi 3. Okay, now the phase angle is increases from 0 to pi 3. The power factor unity to lead decreases. Finally, now do it yourself. I will list 4 questions. The first question is from Tangent Co AE Post 2015 exam questions. The second question is from Maharashtra Public Service Commission's AE Post examinations 2018. Third question is from Tamil Nadu TNPC Tamil Nadu Municipality Water Supply Board examinations 2024. Fourth question is from TNPC Tamil Nadu Municipality Water Supply Board examinations 2024. Okay, just pause these videos, solve these questions, comment your answers. If you have any doubts related to the discussions, kindly post. Definitely you can get the clarifications. Continuously watch our channel. Definitely you can get the good knowledge and you can get the good marks in the competitive examinations. Okay, good. Thank you. Thanks for watching. Click the subscribe button and click the bell icon for notification. Like, comment and share.